The twin Voyager 1 and 2 spacecraft are venturing into uncharted territory, where no Earth-based spacecraft has ever gone before. They've both been traveling for more than 40 years, since their respective launches in 1977, and they're both far away from Earth and the Sun at this point. Despite the fact that both of these probes have been making advances for years, they have finally encountered something concerning in space, sending a warning back to NASA scientists. What did these space probes discover? In this video, we'll take a look at everything you need to know about the unknown force in space Voyager made contact with. Spending 45 years traveling through the solar system takes its toll on a spacecraft. NASA's Voyager 1 mission, launched in 1977, entered what scientists call interstellar space in 2012, and has since continued on its journey. The spacecraft is now 14.5 billion miles from Earth. While Voyager 1 is still operational, scientists on the mission recently noticed that it appeared confused about its location in space without entering safe mode or sounding an alarm. A mystery like this is sort of par for the course at this stage of the Voyager mission. Suzanne Dodd, project manager for Voyager 1 and its twin Voyager 2, said in a statement from NASA's Jet Propulsion Laboratory in California. The spacecraft are both nearly 45 years old, which is much older than the mission planners expected. Dodd added, "We're also in interstellar space, a high radiation environment into which no spacecraft has ever flown. The problem is with Voyager 1's Attitude Articulation and Control System, or AACS, which keeps the spacecraft and its antenna oriented correctly, and the AACS appears to be operational, as the spacecraft is receiving commands, acting on them, and transmitting science data back to Earth with the same signal strength as before. Nonetheless, the AACS is sending junk telemetry data to the spacecraft's handlers. The NASA statement does not specify when or how long the problem has existed. According to the agency, Voyager personnel will continue to investigate the problem and attempt to either fix or adapt to it. That's a slow process, because a signal from Earth takes 20 hours and 33 minutes to reach Voyager 1. Receiving the spacecraft's response takes the same amount of time, according to NASA. The twin Voyager 2 probe, which was launched in 1977, is behaving normally. The power the twin spacecraft can generate is constantly decreasing, and mission team members have turned off some components to save power, measures they hope will keep the probes operational until at least 2025. The engineering team faces some significant challenges, Dodd said. However, I believe that if there is a way to resolve this issue with the AACS, our team will find it. The issue has not triggered any onboard fault protection systems, which are designed to put the spacecraft into safe mode, a state in which only essential operations are performed, allowing engineers to diagnose a problem. The signal from Voyager 1 has also not weakened, indicating that the high-gain antenna is still properly oriented with Earth. Strange signals from space may appear sinister, but NASA's engineers believe they are normal. The team will continue to closely monitor the signal to determine whether the invalid data is coming from the AACS directly or from another system involved in the production and transmission of telemetry data. The team is unsure how long the spacecraft will be able to collect and transmit science data until the nature of the problem is determined. Light travels 14.5 billion miles in 20 hours and 33 minutes. So Voyager 1 is currently 14.5 billion miles away from Earth. That means sending a message to Voyager 1 and receiving a response takes about 2 days. A delay that the mission team is used to. A mystery like this is sort of par for the course at this stage of the Voyager mission, said Suzanne Dodd, project manager for Voyager 1 and 2 at NASA's Jet Propulsion Laboratory in Southern California. Both spacecraft are nearly 45-year-old, far exceeding the mission planners' expectations. In addition, we're in interstellar space, a high radiation environment where no spacecraft has ever flown. As a result, the engineering team is up against some significant obstacles, but I am confident that our team will find a solution to this issue with the AACS. Voyager 1 and 2, humanity's farthest and longest-lived spacecraft, celebrated 40 years of operation and exploration in August-September 2017. In this panel presentation, here are behind-the-scenes accounts from original and current mission team members as they describe the mission's engineering challenges and momentous scientific achievements. JPL recorded this program on August 24, 2017. The Jet Propulsion Laboratory of NASA. According to Dodd, the team may not find the source of the anomaly and will instead adapt to it. If they do locate the source, they may be able to resolve the issue through software changes or by utilizing one of the spacecraft's redundant hardware systems. It wouldn't be the first time the Voyager crew had to rely on backup gear. When the primary thrusters on Voyager 1 began to fail in 2017, engineers switched to a different set of thrusters that had previously been used during the spacecraft's planetary encounters. Despite being inactive for 37 years, those thrusters functioned. Last year, Voyager 1 detected space raindrops gently falling on a window as a low, constant pattering against its detector. Those drops are plasma waves or interstellar gas, which the spacecraft is constantly surrounded by. We're hearing the faint, persistent hum of interstellar gas, said Stella Kokocker, lead author of the study and a doctoral student at Cornell University. It is very faint and monotone because it is in a narrow frequency bandwidth. The monotone drone could be heard for nearly 1 billion miles by Voyager 1, and researchers believe these weak plasma waves are distinct from other detections made in the vast nothingness of interstellar space. The Sun, for example, occasionally becomes agitated and erupts, ejecting particles into space. Cornell astronomer James Cordes compares the outburst's signature to a lightning bolt. The bursts were once used to calculate the density of interstellar plasma, but the low, constant hum indicates that Voyager is collecting plenty of data even when the sun isn't shining. Future interstellar missions would help clarify what's going on out there, and NASA has plans for one in the 2030s. Voyager 2, the twin of Voyager 1, is still operational. Both Voyager spacecraft, launched in 1977, have lasted far longer than mission planners expected and are the only spacecraft capable of collecting data in interstellar space. This region's data has helped scientists better understand the heliosphere, the diffuse barrier that the Sun creates around the planets in our solar system. Each spacecraft consumes approximately 4 watts less electrical power per year, limiting the number of systems that can be operated. The mission engineering team turned off various subsystems and heaters to conserve power for science instruments and critical systems. No science instruments have been turned off due to diminishing power, and the Voyager team is working to keep the 2 spacecraft operational and returning unique science beyond 2025. According to another NASA JPL theory, the Voyager 1 spacecraft appears to be mysteriously confused with data as a result of an aurora on Mars. The physicists looked into discrete aurora, which is a light-in-the-sky phenomenon that happens mostly at night in Mars's southern hemisphere. According to a new study, the properties of the upstream solar wind interacting with the crustal magnetic fields found in Mars's southern hemisphere have a significant influence on the formation and properties of the Martian discrete aurora. The main discovery is that the aurora occurrence rate inside the strong crustal field region is determined primarily by the orientation of the solar wind magnetic field, whereas the occurrence rate outside the strong crustal field region is determined primarily by the solar wind dynamic pressure. The findings are based on NASA's Mars Atmosphere and Volatile Evolution spacecraft's observations of discrete aurora on Mars. Mars aurora research is currently flourishing and exciting. For the first time, we can understand basic aurora features thanks to the MAVEN database of discrete aurora observations. While the engineers work to solve the mystery that Voyager 1 presents, the mission's scientists will continue to make the most of the data coming down from the spacecraft's unique vantage point. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.